Hello, Abusafo. Aha, Koko Chem YouTube channel. In the class, we are going to talk about valencies of common elements. According to structural theory of matter, every element has a predictable number of bonds. Over all these elements, we predict the number of bonds sa atom no and sa element no ebetimi bonded to a different atom and a different element. But say element we be bonded to other element and say another atom, it has something to do with the valence shell electrons. Okay, into a case of valence, valence refers to the number of bonds formed by each element. Into you find be element bit say carbon. The number of bonds na carbon ebitimi a form any friend valence. Okay, you will tetravalent, trivalent, divalent, monovalent. A case be a tetra. Tetra means 4, tri means 3, di means 2. Have you picture no? You can mono, you can say a be a mono, it is 1. Okay, you can say be a tetravalent, it is the number of bonds are element in bit me form is 4. Example, so carbon generally forms 4 bonds. Into carbon where wahana, it has 4 connections. Connections in a bond. Into which me the atom and element has a H. All bonded to the central element in our carbon. In terms of carbon, I form 4 bonds, tetravalent. For illustration's sake, when set black ball, carbon. Let's assign white balls, okay, as hydrogens. Yeah, for me, tetravalent bonds are carbon na. Yeah, connect here. You connect one hydrogen has another hydrogen another hydrogen and another hydrogen near forming methane. Later on, we'll go on to more details, but carbon has 4 bonds now. 1, 2, 3, 4. And we have the central carbon in the middle. Okay. So this is an example of tetravalent. Okay. You can be a trivalent. That means it can the number of bonds that element can form is 3. Example, nitrogen. Assuming say this yellow ball is nitrogen, that means how many bonds would nitrogen form? So the predictable number of bonds is 3. So we can have hydrogen bonded to the nitrogen, another hydrogen, and another hydrogen. Okay. So in that instance, if we are forming trivalent, we can connect one hydrogen to the bond coming from the nitrogen in the center. Okay. Another hydrogen there, and another hydrogen there. So you have a trivalent atom or a trivalent element. Divalent form how many bonds? 2. An example is oxygen. So assuming say we take this red ball as oxygen, so oxygen will have 2 bonds. So an example can be oxygen bonding to hydrogens to form water. So we can have O in the center, bonded to hydrogen, okay? So again, we are using the white balls as hydrogen, the red ball as what? Oxygen. So you connect your hydrogen to the oxygen in the center, and then you connect the other hydrogen to the other side. Now you have 2 bonds connected to the central atom, which is oxygen. So oxygen is an example of a divalent atom or a divalent element. Monovalent, a case of monovalent, it's just that atom or that element, the number of predictable bonds a bit more formula than 1. Mono means 1. An example is hydrogen. Okay, hydrogen in this instance, X can be a halogen. An example of halogens will be fluorine. Yeah, you are right. Fluorine, chlorine, bromine, iodine. Okay. So for example, we can say this is a hydrogen, Okay, it has only one bond sticking out from the white ball. This guy can be a, you can designate it by anything. You can say this guy can be a bromine. You see one stick coming out, that means it's a monovalent. Okay, this guy can be a chlorine. You see one stick connected to the chlorine. This guy can be, iodine. The colors of these are not fixed. Okay, so you can designate them as you wish. Okay, so this can be your iodine having one stick as a bond coming out from it. Okay, so yeah, just for a recap, valence refers to the number of bonds that an element can form. I thank you so much again for learning chemistry with Coco Chem. Okay, have a great day and see you next time. Bye bye.